Hello, this is our final presentation for Senior Design. We are BYEas by Chloe Hutchins, Monica Kavathekar, and Jennifer Wright. So what is BYEas? BYEas is a lightweight, easy-to-use web plugin that shines a light on the potential biases that are present in the everyday sources we use. We do this by presenting bias scores for the features related to the male and female categories and doing some data visualization. We're also able to highlight some phrases that are potentially the most noticeably biased in the article you're looking at.
So now we're going to dive into why you should use BYEas and why we need it. So first, diversity begins with the material we are exposed to. In our presentations, we've discussed an article with the title Math equals male, me equals female, and therefore math not equal me. This is basically a metaphor for a bunch of articles and content that young girls or anyone could be viewing online. We're not really aware that this content is biased, even though the implicit biases that exist in our society may be embedded into this text. This is one reason why we need to use BYEas, to expose opinion pieces and articles that actually have a subconscious bias. Because of all of this, we want to shine a light on the bias. Unconscious bias is one of the biggest issues that we face today in diversity. A lot of the stereotypes and bias that we hold inside of us may not completely be conscious. They're simply embedded into us and the content we read online from a young age. That's why BYEas aims to shine a light on this bias and expose our subconscious feelings. And finally, we want to harness the power of machine learning. Artificial intelligence is growing more and more prominent in today's society. We want to use this technology for good, and that's why we decided to create BYEas. In the modern day, we have so much access to tools that can make us better people, so we wanted to use this to create something useful for the common good. Alright, so next we're going to be talking about how BYEas works. So here we have a high-level overview of the workflow of BYEas. So first, a user chooses an article. Then they'll open the BYEas extension that they have installed in their web browser, click our Compute Score button, and then they'll be redirected to our BYEas dashboard so they can view the BYEas data and a lot of fun information and facts about the article that they've clicked on.
This slide shows a diagram of the system architecture we used for our project. As you can see, a user will interact with the web plugin and the bias detection dashboard. The web plugin allows us to access and pass the URL of the current website being viewed to our API, which is done on the dashboard side. The API then does the web scraping and the data processing. Our algorithm takes place here and interacts with our database in order to speed it up and pull any values needed. Then JSON will be returned to the dashboard and displayed for the user to view. We use a HTML and JavaScript client with the model view controller pattern for the front end, and we use Swagger to route the API calls and Flask and connection to set up the Python server.
So some of the APIs and packages we use in order to set up our system architecture are listed here on this slide. As Jen mentioned, we use Swagger to create a custom API in order to send the data from our URL into our Python backend and then send the JSON file with the bias data back to our front-end dashboard. We had to create a custom API using Swagger, and those are routed through post requests that lead to the proper functions in our Python file. Then we used Ajax and jQuery to send and receive the data. So Ajax is able to send a data request and pass the URL of the page into the backend and then receive the JSON file and pass those numbers into the front end. And finally, we used Flask to set up our server and fully wrap our backend and front end together.
For our client, which is our web plugin and our dashboard, we decided to use HTML and CSS for the front end and formatting, and JavaScript in order to deal with the data, and the model view controller pattern in order to accept data that is received and make sure it is displayed properly. In order to communicate between the web plugin and the dashboard, we use listeners. You are able to specify in the manifest which external websites you can connect to. So through this, we are able to connect with our dashboard. And finally, we are able to query the DOM in order to do our highlighting, which allows us to modify the HTML of the page that the user is viewing.
The part of the project that I'm going to be describing is the algorithm for how we calculate the bias scores. The basis of our algorithm was the GLOVE word embeddings. GLOVE is an unsupervised learning algorithm which creates vector representations of words. These word embeddings are created based on how often the words co-occur in a text corpus, and therefore creates a meaningful mapping of the words based on their semantic similarity. For our project, we used a pre-trained data set with about 2.2 million word embeddings, which was created by a common crawl of the internet. What our algorithm does is it takes the string of the article's text created by the web scraper, removes the punctuation, and then splits it into a list of the words. Then, the algorithm checks if the words in the list exist in our database and removes them from the list if they don't. Then each word in the list is compared to our different bias categories. Each bias category is made up of a list of words that are associated with that category. For example, the female category is made up of the words sister, female, woman, girl, daughter, she, hers, her. The list of words we use to represent each bias category were chosen because research by Professor Koliskin showed that these words could accurately represent human semantic biases. The biases that we calculate for our project are the male math female arts bias and the male career female family bias. So the article's list of words are compared to each of these bias categories. The way that we compare each of the words in the article with each of the words in the bias categories is by calculating the cosine similarity of their word embeddings. This is done by calculating the dot product of the vectors and then dividing it by the product of each vector's magnitude. What cosine similarity tells us is that the closer to 1 it is, the more similar the words are, and the closer to 0 it is, the more different the words are. For each bias category, we get an average of the cosine similarity values and then use these to calculate the effect length. The effect length is calculated by subtracting the mean cosine similarity values for the two categories you're comparing and then dividing this by the standard deviation. For example, for the male math female arts bias, one of the comparisons we would make is between the female and math categories. To do this, we would subtract the mean cosine similarity of the female category and the mean cosine similarity of the math category, and then divide this value by the standard deviation of the set. What effect length tells us is the importance of the difference between each of these categories. The smaller the effect length, the more similar, and the larger the effect length, the more different.
Now we will show you a demo of our final project. Here is the video demoing our project. So you can see we start by starting our server, and then we go to the internet and we refresh our Chrome extension to make sure it's up to date. Next, we're going to refresh an article to make sure no changes have been made and it's fresh. As you can see, no highlighting there already. Now we're going to use our web plugin. So we click to compute the score. You can see that we have some data visualization and we end up on the dashboard. The highest and lowest scores are bolded. Descriptions of how we calculate the scores and how you can interpret them. And finally, some information about our team. So this would be the basic user process for our product. Finally, we have the highlighting of a biased sentence.
Thanks for listening to our presentation, and make sure you download BYEas from your extension store today.